Hello students, welcome back to this new session. Now let us continue with the problems on the previous session topics, that is Cauchy's theorem and Cauchy's integral formula. Now we will start with the problems based on the two topics which we did in my last session. Okay, so here is the problem. Verify the first problem for you. Verify the Cauchy's theorem for the function f of z is equal to z square, where c is a square having the vertices 0, 0, 1, 0, 0, 1 and 1, 1. Okay, so what do you mean by verify the Cauchy's theorem? See here, what Cauchy's theorem says: whenever f of z is analytic inside and on the closed curve C, then integration over the closed curve C, then integration over the closed curve C, f of z dz is equals to 0. This we have to prove. F of z is z square here. Now z square, you all know, it is analytic, it is differentiable, right? And hence you have to prove Cauchy's theorem or verify Cauchy's theorem that integration over the curve C, f of z is equal to z square dz is 0, where C is this square having the vertices 0, 0, 1, 0, 0, 1 and 1, 1. For that, the solution, to start with the solution, first let us consider what is our curve C. Okay, let us draw and take it. Okay, so here we have x-axis, y-axis and the origin. Okay, so this is the point 0, 0 origin. Next point is 1, 0, so it will be, suppose I'll mark it here 1, 0. Next is 0, 1. I'll mark it somewhere, say this is 0, 1 here. Then draw a parallel line like this. So definitely this point will become 1, 1. So you can join this. So this is your square and the curve C is going like this. I'll mark these points now: O, A, B and C. So O, A, B, C, O is the curve C. Okay, the points A, B, C I have marked there. So the curve C is the curve C is the path, okay, is O, A, B, C, O. It's a closed curve like this. Okay, now yes, it's given that f of z is equal to z square. So if you put z is equal to x plus I y, so f of z will be what? It will be x plus I y whole square, or it is x square minus y square plus 2ixy. I hope it is clear. X square plus I square y square. I square is minus 1, so you will have this plus 2xy. Just apply the formula a plus b whole square, you will get this. Okay, now I have z is equal to x plus iy. So what is dz? It is dx plus I dy. So how will my integration over the curve C f of z dz look? It will be integration over the curve C. Yes, f of z is this, right? F of z is x square minus y square plus 2ixy into dx. Dz value you have to substitute, which is dx plus I dy. Write that as well here. Okay, I hope it is clear up till here to all of you. Yes, now this is equal to integration over the curve C. Now multiply this with this. See here, separate the real and imaginary parts from here. Okay, always remember, whenever you multiply a real part to the real part, you will end up with the real part, and when you multiply the imaginary part with the imaginary part, you will end up with the real part, because I into I will get you I square, and I square is minus 1. Okay, so you have to replace that value. That's the only thing. Okay, so you will get x square minus y square. This is the real part of the first this, and this is the imaginary part v. This is u. Okay, so the real part is this into dx, first real part, and if you multiply this imaginary part with this imaginary part, you will get minus 2xy dy. This is the real part. This is the real part. Plus, now I will consider only the imaginary parts. So take a big bracket I into the imaginary part. So if you multiply real part with the imaginary part, you will get the imaginary part. So x square minus y square dy, and if you multiply the imaginary part with the real part over here, you will have again imaginary part 2i xy dx. You will get it something like this. Okay, now complete that bigger bracket. Okay, now let us separate and write everything together. So you have integration over the curve C. All dx terms you can write one side, or all dy terms also you can write one side. That also can be done. Okay, or else you can just write everything properly and keep it aside. How? I'll just separate the real and imaginary part. That will be better for me. So it will be x square minus y square. Where and all I have dx here. That will be better if I connect only the dx terms to one side. Plus 2i xy dx. No need to further simplify or anything. Okay, now write all the dy terms to one side. It is I into x square minus y square minus 2xy, this into dy. This is dx term, these are dy terms, nothing else. No need to separate the real and imaginary parts. We can proceed with the solution in just a simple way like this. Okay, now yes, our curve C is made up of many parts. First is OA, then AB, then BC, then CO. Then it becomes a complete closed curve C. As I have told you, the curve C is OA, BC, O, right? So part by part we will be solving it, because yes, and also right here, also integration of the curve C f of z dz is also equal to integration along OA z square, because f of z is z square dz, plus integration along AB z square dz, plus integration along BC z square dz, plus integration along CO z square dz. You will get it like this. Okay, now once you get all this like this, you have to discuss along OA what is happening. On OA, just see what is happening. Go back to your curve. See, along OA, it is but the x-axis. If it is x-axis, you will have y 0. So definitely dy will also be 0. And how is x varying? X is varying from 0 to 1. You see that. So x varies from x is equal to 0 to x is equal to 1. You can take it like this. Okay, I write it here. Okay, this is one thing. Now along AB what is happening? AB is the line parallel to y-axis, but look at this, x is 1 at the initial point at A, and at the point B then also x is 1. So x is fixed, it's not varying. X is equal to 1, that is it's constant. Similarly, look for y is varying from 0. At A it is 0, at B it is 1. So y is varying from 0 to 1. You can write it. So x equals 1, and since it is not varying, therefore I can write dx is equal to 0, and y is varying from y is equal to 0 to y is equal to 1. I can write it like this. Similarly, along BC, look at that, what is happening? Yes, x is 1 at B, but x is 0 at C. So x is varying from 1 to 0, and what is happening with y? Y is 1 at B as well, it is 1 at C. So there is no variation for y along BC. So I can write it that same thing. So y is fixed, it is 1, right? So therefore dy is once again 0, because there is no variation in y. So we can directly take the variation in y to be 0. Then y is varying from, sorry, not y, x is varying. X varies from x is equal to 1 to 0 this time. Yes or no? Please make a note. Okay. After that, along CO, it is, yes, let me show that in the figure. Along CO, this is y-axis. So on y-axis, x is 0. So directly you can take x 0. So dx will also be 0. Then what is happening with y? Y is 1 at C. But as you move along from C to O, y is taking value 0 at the origin. So therefore y is varying from 1 to 0. So write the same thing. So x is 0 along CO. So therefore dx will also be 0. And y varies from y is equal to 1 to y is equal to 0. Hence, we have written all the required variations for each of this, and yes, we will directly substitute now, okay? Therefore, integration over the curve C f of z dz will be equal to along OA. What is happening along OA? Y is 0, dy is 0. So, I have integration over the curve C f of z dz like this here. Right? So, it is same for this function. It's going to be the same for every part here. Okay, we have z square dz here, right? So in this we have to substitute all these things. Okay, now since I am speaking in particular about OA, along OA what is happening? Y is 0 means this is 0, this is 0, this is 0, right? And you have y is 0 means dy is also 0 means this complete term is 0. You need not consider this term at all because dy is 0. Here dx is not 0, but wherever it is y you have to put 0. So what do you get? Yes, what do you get? Z square dz as x square as it is. Look at this, x square as it is. Y is 0, so need not to write it. Since y is 0, 2i xy will turn 0. So dx as it is. Done. And since y is 0, dy is also 0. So this complete term is 0. So no need to write there. And how is x varying in that? X varies from along OA. X varies from x is equal to 0 to 1. So x varies from 0 to 1. Directly you can take it. Plus under integral sign along AB what is happening? X is 1. You have to put x as 1. In this only you are going to put x is equal to 1. Dx 0 means dx means 0 means this part is 0. We are now speaking about OAB. Along AB, x is equal to 1. Wherever it is x, you are going to write 1. Dx is 0 means the first part is completely 0. Only this you have to consider. Okay, if you consider this, yes, you have to put x, and there also you have to put x is equal to 1 and y is varying from 0 to 1. So y is varying from 0 to 1 along AB and x is equal to 1. So I'll write it here. Into x is 1 minus y square, because 1 square you get it as 1, okay, minus 2 x is 1, so y you get this into dy. This completes for AB. Now plus along BC. Along BC what is happening? Y is 1, dy is 0. Dy is 0 means directly you can consider that this second part is no need to consider it at all. Next, how is x varying? X is varying from 1 to 0. Write that 1 to 0. X is varying from 1 to 0, dy is 0. So directly we have done. Now you have to write remaining part as it is, and writing x is equal, y is equal to 1 everywhere. Look at this. In this first part also, second part is at least 0 along BC, but y is 1 in the first part. So y is 1 means x square minus 1 square, which is 1, plus 2i. X as it is, y is 1. So it will be dx like this. Okay. Plus the last integral we are writing now. It is integration along CO. X is 0, dx is 0. So x is 0 means dx is 0 means the first part is 0. And here also you have to put x 0. And you have to consider the remaining part. And how is y varying along CO? Y is varying from 1 to 0. So y is varying from 1 to 0. Just substitute x is equal to 0 and y as it is. So x is 0, no need to write it. Look at this. X is 0, no need to write. Minus y square you are writing. Minus y square. Since again x is 0, so 2xy turns 0. You will have only dy over here. Okay, I hope it is clear to all of you. Now let us move to, so now let us integrate and simplify and get the final answer for this. You have integration of x square dx, so it will be x cubed by 3 with limits from 0 to 1, plus I as it is, integration of the term inside the bracket, which is y minus y cubed by 3 with limits from 0 to 1. Okay, minus integration of 2y, which is y square with limits from 0 to 1, plus integration of this, it is x cube by 3 minus x, the next term, okay, 1 to 0 this time, there is plus in between, and I as it is integration of 2x, it is x square with limits from 1 to 0, okay, plus okay, I'll take that minus sign outside, so minus I y cube by 3 integration of y square with limits from 1 to 0. Okay, I hope this is clear. Now let us simplify it further. If you write, I'll write it a little here because I want to continue it here itself. Okay, so if you put x is equal to 1, it will be 1 by 3. 1 cube is 1 divided by 3. Lower limit is 0. No need to write it. Okay, plus the next value, I as it is, integration, substitute the value for x, y is equal to 1. So 1 minus 1 by 3. And when you put 0, the lower limit is 0. So no need to write it. Minus the upper limit is again 1. 1 square is 1 only. So minus 1. Lower limit is 0. So I am not writing it. Plus the next term. When you put the upper limit, it is 0. So write it as 0. Minus the lower limit, x equals 1 means 1 by 3. Minus of minus plus 1 you get. Plus I. Upper limit 0 minus lower limit 1. Minus I. Upper limit 0 minus the lower limit 1 by 3. Okay, now further simplify this here itself. See, it is 1 by 3. And when you simplify this fraction, you have, it is 1 minus 1 by 3 is plus I into 2 by 3 minus 1 plus 1 by 3 minus 1. It's 2 by 3 plus 2 by 3 minus I plus I by 3. Okay, now you just see that. Just see, plus 1 by 3 plus 2 by 3. It's 1 plus 1 minus 1, right? Plus 1 minus 1 you get. Collecting all the items, you have 2 by 3i plus I by 3 is plus I, and you have a minus I also here. You see all getting cancelled. We are getting 0. Hence, we have verified the Cauchy's theorem for this curve. All you have to do here is, just I'll repeat it. What you have to do? Yes, given any problem to you, you have to first consider the curve. Look at how the closed curve is given to you. Okay, and try to consider, take the function f of z, find out what is f of z dz, like how we have done it here. Okay, f of z dz, all that, and multiply both, and try to separate all the dx and dy terms, and write your what is integration f of z dz over here. Now you already know this stuff right from the properties of integrals. Okay, since the curve is made up of so many parts, integration along f of z dz will be integration along each of the parts. Okay, that you know very well. So from each of the parts we go on substituting. We see along A what is happening, how is x and y are varying along AB, along BC, along CO. Do all those things, see the figure and identify how are the variables varying along those line segments. Okay, after that substitute the values, you will see all these getting, okay, and just integrate, simplify, you get the value to be 0. Hence the Cauchy's theorem is verified. Okay, continue in my next session. Thank you.